Let's have a look at this word problem. A circular wine barrel, 75 centimeters in diameter, will burst if the net upward force exerted on the top of the barrel is 6430 newtons. Let's draw a picture of this, and I'll leave the rest of this here for you to read. So let's draw a picture of what this is all about right here. So we have a barrel. Here's a barrel. And it looks something like this. And it's filled with water, or in this case, wine. It's a wine barrel, so we'll go with wine. And it's filled all the way to the top with wine. And it has a lid. So here is a lid. And on this lid, there is a small hole. And the lid is pushed down into the wine barrel. So we're going to drop the lid down in here. And some of this wine right here is also going to gush out such that when this is finished, it'll look like this. And so the lid will be here. And it'll be held in place strictly by friction. It's being pushed down, so it's going to push out the sides a little bit. So it's being held here by friction and a little bit of inward force. And it has this hole here on the side. And it is completely filled with wine all the way up to the top of that hole. So all the way right up in here is completely filled with wine. And you can see the wine just about to overflow over this hole. And then we're going to put a tube here. And we're going to fill up this tube with, say, water. As we fill up the tube with water, a pressure will be built down here. There is going to be a pressure from the weight of the water pushing here. And the question is, how much, let's see what it says here. What height of water must be poured into the tube in order to burst the barrel? What height of water up to here? Initially, the barrel filled to the top and the tube is empty. What weight, my mistake, what weight of water must be poured into the tube? So we want to know the weight. The weight of the water up to here. In another video, I will solve the height of the water. I'll solve for height in a separate video. For this video, I'm going to solve for weight. And we're told here that the amount of force needed to break that seal here, this friction and slightly pressure seal right there, the upward force needs to be 6430 newtons. So let me redraw this diagram over here. Here is the barrel. Here is the lid. And the lid is strictly a pressure fit and with friction. Just by the shape of it, it's just being held in here, and it has a little bit of thickness to it, so I'll just draw a little bit of thickness, something like this. And it's strictly being held here by a little bit of resistance, or let's call it friction, right here at this point. And a little bit of inward force. But it's not mechanically put in here with a screw or anything like that. So it can be popped up. And the amount of force required in order to pop this up is going to be 6430 newtons. We'll call that force 2. And over at this side right here, we have a tube. And this tube here is filled with water. And this water is applying a force here at the bottom. The weight of all that water is applying a force here at the bottom. And we'll call that force 1. There is a diameter for this tube, and the diameter is given to us as 1 centimeter. And the diameter of this barrel from here to here, that diameter, we'll call that diameter 2, call this diameter 1. That diameter is given to us as 75 centimeters. So what we have here is a case of Pascal's principles, or Pascal's law. I like to use Pascal's law. So I'm going to redraw this in a more familiar picture. Here is the small end of a tube, and here is the larger end. I'm going to redraw that to something that's more familiar to us. Here is the small end. And now I'm going to draw this portion. Here is much larger end. Everything here is at the same height. Okay, so the height of the liquid here is the same as the height of the liquid right here. And we'll just connect these up. So here is another depiction of this picture. And the force pushing down right here, well, that's going to be the weight of this water column. And that's what we need to calculate. Because our first question here is going to be what weight of water must be poured into this column, what weight of water. And in a separate video, I'll calculate the height of that column. And we'll call that force 1. And you know that weight is a force of weight. So we'll just call that force 1. And the diameter given to us here is 1 centimeter, and we'll change that to meters, 0.01 meter. And we know that the force needs to apply here in order for it to burst. Has to be, F2 is 6430 newtons. And we know the diameter here, call it diameter 2 is equal to 75 centimeters, and we'll simply convert that to meters, 0.75 meters. Now we're going to apply Pascal's law. Force at 1 divided by the area at 1 is equal to force at 2 divided by the area at 2. So over here on the side, we know the forces we're looking for. We need to calculate the areas. So I'll just do them over here on the side. Area 1. This is circular in shape. So the area of a circle is pi r squared. And that's equal to pi times 0.01 meters, divide that by 2, all squared. And that number comes to 7.854 times 10 to the power of minus 5 square meters. And for area 2, that's this area here, or the area at the top of the barrel right here. Again, it's going to be pi r squared, and the radius of this is 0.75 divided by 2. Everything squared. And that number is 0.41786 meters squared. So we have the information that we now need in order to solve F1, where the weight of the column of water applying here at this point. Rearranging this equation just to solve for F1. So we're going to move A2 to the other side. F1 is equal to F2, going to move A1, multiplied by A1 divided by A2. Putting in the numbers now in order to calculate force 1. And that's the same as the force of the weight of the column of water. And that's all equal to force at 2, that is given to us here, 6430 newtons. Area 1 is this value, 7.854 times 10 to the power of minus 5 meters squared. Everything divided by area 2, 0.441,786 meters squared. Meters squared cancel out, leaving us with newtons. Force 1 then is equal to 1.1425 newtons. Therefore, the total weight of the column of water needs to be 1.1, if we draw that here, here's the barrel. And there is a column of water here. And the weight of the column of water being measured at this point has to be that value. And in a separate video, I'm going to calculate what this height needs to be. Reducing this to significant figures, what do we have here? 2 sig figs, 2 sig figs. So force weight, force 1, approximately 1.1 newtons.